Hey guys, today we are going to be talking about solving quadratic inequalities. So we're given a quadratic inequality and we need to find what x could be equal to. So this is going to be giving us a solution set. So it's not just one x is our answer, which is very similar to what we talked about previously when we were dealing with graphing quadratic inequalities. Anything that was in our shaded region, any point in that shaded region was going to be a solution. Here, when we're only dealing with x's, the other ones were equations where we had y's in them as well. So the solutions were point. Here, our solutions are just going to be x values. So instead of representing it graphically, we're going to represent it on a number line. So let's get started. So our first step is to solve the quadratic inequality to find the zeros. And recall that zeros are the same thing as roots as well, or solutions. So we have several techniques here to be able to solve an equation. And so this is good practice for helping us identify what method we should use to solve it. So when we are factoring, that means we can factor it because it's factorable. Just a good reminder is when we're solving by factoring, you have to get one side equal to 0. When we have the roots method, that's when we have b is equal to 0. We have no b value, or we're in vertex form. In those scenarios, it's good to use that method. Completing the square, when you can use it when your a value is 1 and your b value is even. Those are the two ways we learned. Again, I'm not a huge fan of completing a square, so I'm not going to use it very often. I would rather, if I couldn't have any luck with any of these methods, I would use the quadratic formula because it always works. And another good reminder for the quadratic formula is that you also have to get one side equal to 0. So let's take care of this first step by solving this. I'm going to get one side to be 0 to see if I could factor it, and then if not, I could use the quadratic formula because I can't use the root method because I have a b value. So I'm going to subtract 15 on both sides. So one side 0. And here, let's see, can I factor it? So what two numbers multiply to negative 15 but add to negative 2? Well, that's going to be x minus 5 and x plus 3. So it is factorable. And then from there, I'm not really worried about the symbol anymore. If you want to put an equal sign, if you want to keep the symbol, it doesn't matter. I'm not so concerned about what's going to happen with it because once we draw our number line, we're just going to test each section, and that's going to help us figure out our directions. So here, that means we're going to have x is equal to 5 and x is equal to negative 3. So negative 3 and 5, and we're going to draw a number line. We have our zeros, and then we're going to test a number between each interval. So 0 is between these numbers, so I'll test 0, I'll test 6, and I'll test negative 5. It doesn't matter. You have to pick one that's not there. So if I test negative 5, I'm going to actually test negative 5 in here, and I get negative 5 minus 5 is negative 10 times negative 5 plus 3, which is negative 2. So negative 10 times negative 2 is a positive 20, and 20 is greater than 0. That is true. So that would mean that's something I'm shading. If I'm testing 0, I'm going to put it in here. I think that one might be easier for this scenario. This ends up being 0, 0. Negative 15 is greater than 0. That's not true, so I wouldn't shade there. If I test 6, I'll test 6 back in this one again. Doesn't matter where I test it because these are equivalent. So that would be 36 minus, that's going to be 12, so that's 24. 24 minus 15 is going to give us 9. So 9 is greater than 0. That is also true. So I'm going to have an open circle here, open circle there, because I don't have an equal to line. And then I shade that way and I shade that way based off my tester points. And then we need to write our solution in interval notation. And I also want us to write it in inequality notation. So we're going to have negative infinity to negative 3, u 5 to infinity. And we're also going to have that x is less than negative 3 or x is greater than 5. And that's how we can represent both there. Okay, so moving on to this next problem. I need to think about which method I want to use. I can try factoring. I can't use the root method because it's not, I have a b value and it's not in vertex form. I'm not going to complete the square because I have an odd b value and my a value is not 1. So factoring or quadratic formula. So I'm going to try factoring just because I think factoring can be a little bit easier than the quadratic formula. So I would need to use the AC method. So I want two numbers that multiply to negative 8 but add to 1. And you're going to exhaust all the possibilities because that is not possible. It is prime. It can't be factored. So we're going to jump to the quadratic formula because that's what we have left. So quadratic formula is x is equal to negative b, negative 1, plus or minus the square root of b squared, 1 squared minus 4 times a, which is 2, times c, which is negative 4, all over 2 times 2, 2a. I'm going to simplify what's under the square root to start. So this is 1 minus, so 4 times 4 is 16, times 2 is 32, and it's actually going to be plus because I have two negatives, and then over 4. So I get negative 1 plus or minus the square root of 33 over 4. And I can no longer simplify this any further. And due to this situation, I am going to allow us to use our calculator because it's going to help us pick our tester points because we need to get an idea of where these are on our number line. So I want us to type them into our calculator, find it out exactly. So we're going to have negative 1 minus the square root of 33 over here over 4, negative 1 plus the square root of 33 over 4 here. I could be really, really mean, and you need to estimate what these are on your own, but I'm going to be really nice and let us use our calculator here. So negative 1, and I'm actually going to put this all in parentheses, negative 1 minus the square root of 33. Oops. I need to put a right arrow to get out of the square root and then put my parenthesis, then divided by 4. So this is about negative 1.69 roughly. And then I'm going to just do up, up, enter. And then I can just kind of use my arrow back so I can change that to a plus. And that's approximately 1.19. So I can pick tester points in between. Let's pick them at 0. 0 is always a good number. Let's do 2 and let's do negative 2. So picking our tester points, if I put in 0, I get that you've got 0, 0. So negative 4 is greater than 0. That is not true. X. Let's try 2. So that would be 2 squared. 4 times 2 is 8. Plus 2 is 10. Minus 4 is 6. 6 is greater than or equal to 0. That's true. Negative 2. So that's still going to be 4 times 2. That's 8. And then minus 2 is 6. Minus 4 is just positive 2. 2 is greater than or equal to 0. That's also true. So that means I'm going to have a closed circle there. Closed circle there because I have an equal to line. And then I'm shading to the right where it's true. Shading to the left where it's true. So that tells me my solution set is from negative infinity to negative 1 minus square root of 33 over 4. And I use that because it's more accurate than my approximations. U, negative 1 plus the square root of 33 over 4 to infinity. And then also I can write this in interval notation as x is less than -3, or I'm just copying from the previous one. At that point, that should be -1 minus square root of 33 over 4, or that we have x is greater than -1 plus the square root of 33 over 4. If we ended up shading in between, our inequality would be one inequality, and we would do our number less than x is less than whatever that number is to show that we are in between. So next, I would like you guys to go ahead and try all three of these on your own. You're going to have to figure out how to solve them. Once you find your zeros, your roots, you're going to put them on a number line. You're going to test the points in between and figure out where you're shading. Write it as a interval notation and a inequality. So pause the video here, give it a go, and we'll go over it. Okay, so here I decided to solve using the root method. And again, don't really focus on the inequality sign. We just want to get to here, put our points down. I use my calculator to approximate what they are. I have two open circles because I don't have an equal to line. I pick my tester points. Here's a little bit of my work there. I got that I was correct in between for my tester points, so I shaded in between. Here I have it written as here I have it written in interval notation, and here I have it written in inequality notation, where it's a single inequality. For the next one, I also decided to use the root method because I didn't have a b value this time. And so I got plus or minus 4. I picked my tester points. I was on the outsides. So I have inequality notation and interval notation there. For this last one, I decided to get it equal to 0 and see if I could factor it, which I could, which was lovely. I used the AC method, and I got x was 3 and -1/2. Put those there. I picked some tester points, as you can see there in blue, and I got that I was in between -1/2 and 3, and I need to make sure I write the interval notation there, and below is the inequality notation. If at any point you need to look at those further, just pause the video, go back. If you have any other further questions, make sure you ask them. Otherwise, have a great day, guys.